Patty Madigan. I work for the Mendocino County Resource Conservation District, or RCD, as a Senior Conservation Programs Manager.
I'm Colin Hughes. I'm an engineering geologist with Pacific Watershed Associates, a geologic and engineering consulting firm that specializes in watershed restoration and rural road stormproofing.
Today we're out here filming a video to convey information about stormproofing rural roads. We have had handbooks, we've had workshops. This is just another means of outreaching to the public. RCDs work to help landowners be compliant to water quality laws and Endangered Species Act provisions. We're the one-stop shop for them to get help to develop a project, to fund a project, to implement a project, and to actually help communities be better conservationists and to improve the quality of life for wildlife and people.
PWA provides the engineering and geologic technical expertise to facilitate conservation projects to address erosion and sediment delivery issues associated with poorly maintained rural road systems. In the handbook, you'll find specific examples, photographs, and descriptive content on how to install many of these road drainage features and stormproofing treatments that are itemized in this video. The treatments in the handbook for forest, ranch, and rural roads have been accepted and supported by numerous agencies, including the California Department of Fish and Wildlife, regional water quality control boards, and have been very successful in developing the planning that's required to obtain grant funding to address some of the issues with rural roads that lead to erosion and degradation of the road systems and sediment delivery to watercourses. It's really important to address roads because they're widespread on the landscape. They are the ways that each of us and our families get home and to school every day and are traveled almost without thinking by all of us. The impact of those road systems on our watershed health, aquatic habitats, and beneficial uses of water, including drinking water resources, are significant and many times unrealized. Rural roads are often overlooked on the landscape, but they are the greatest source of pollutants to the watershed stream systems. Concentrated road surface runoff results in accelerated sediment production from the road surfaces. Rill structures like these are a result of an undrained road reach and the concentration of road surface runoff. Surface erosion features such as this rilling can be addressed by installation of road drainage structures such as rolling dips and road shaping such as insloping, outsloping, and crowning. This road was constructed several decades ago and is located in an intergorge hillslope position. Intergorge hillslope positions are the last break in slope leading to a stream channel with slope steepness in excess of 65% and are often subject to debris landsliding.
We have a number of distinct problems associated with this particular road reach. However, these can be real typical on other watershed locations in similar areas. We see here that the road has been built through the stream valley here. So that in itself can cause a variety of problems associated with in-stream channel effects. You can have hydraulic effects associated with constricting the channel flow. which could cause bank erosion, scour within the channel, or accelerated sediment transport. Additionally, because where the road has been built in the valley floor here and the proximity of the road to the stream, it becomes very difficult to hydrologically disconnect the road from the stream valley. As you can see, looking up the road here, we have a significant segment of road leading right down to where the stream valley crosses the road here, and any sediment and water coming off of that road will be discharged directly into the stream. You can have secondary BMP measures that will minimize that to a certain extent, but because of the proximity to the stream, it becomes very difficult to do that. At this particular location, we have a severely undersized culvert for the crossing itself. As you can see, we've got woody material rafted near the inlet, and we got sediment deposition. So the problems associated with this sort of structure are that when we have high flows that exceed the capacity of the culvert, we can have sediment deposition and large woody material rafting into the culvert inlet and causing that to plug and overtop the crossing. That can actually wash out the crossing and or divert down the road and cause significant gully erosion at various locations down the road. Additionally, this particular culvert is completely out of alignment. It's too short and skewed to the right and should be elongated and lengthened in the opposite direction, thereby having a better hydraulic conveyance for both sediment and water, as well as potential fish passage issues. Due to the severely undersized nature of the culvert, the high plug potential, and the alignment, this particular crossing overtops on a fairly frequent basis, and in doing so causes significant gully erosion of the fill slope, and at various locations down the road as it diverts and flows back into the stream valley. At this particular site, we have the potential for a complete catastrophic failure of the crossing. And if that happens, or when that happens, if this is not upgraded, this is basically going to lock out access to over 50 families that exist for miles down the road past this location with no emergency access other than this particular site leading out.
This is a typical characteristic of a poorly installed culvert. This culvert is not installed at the natural stream gradient and not installed at the base of fill. Instead, it's high and short in the fill. As a result, outflow from the culvert outlet has fallen steeply onto the fill slope and eroded the fill slope in a large splash zone, delivering approximately 25 cubic yards of fill and some native material to the downstream channel. That development of the splash zone is further destabilizing the outboard edge of the fill, reducing road width and allowing for potential future erosion.
So here's a good example that shows the importance of the concept of hydrologic connectivity. As you can see here, we have a connected road surface that's leading down towards this bridge, which is a discharge point on a perennial stream channel. And as you can see, fine sediment is being generated along this road surface and thereby being conveyed right directly to the stream channel. So in order to prevent this, this is where you would disconnect the road by road shaping, by putting either rolling dips, outsloping, crowning, additional ditch relief culverts on the upstream direction, thereby disconnecting that fine sediment contribution from the road surface as much as possible. Here's another example of a road segment with existing poor road drainage issues. What we have here is you have approximately 1,000 feet of road that's been insloped through the entire reach, and it is concentrating flow and runoff into the inboard ditch. Subsequently, all the water and sediment, fine-grained sediment that's being generated is discharging and depositing into the ditch and subsequently into the stream crossing just beyond that. So what you have here is kind of a point in time. It's kind of like a conveyor belt that suddenly has just been turned off. And all this fine sediment that's now deposited into this ditch, as soon as the rain and runoff happens again, will suddenly turn the conveyor belt back on, and all that fine sediment will continue to be delivering into the stream channel.
Successful road stormproofing and hydrologic disconnection of road surfaces from the stream system is achieved through a combination of road shaping techniques and the installation of road drainage structures such as ditch relief culverts and rolling dips. Road shaping includes insloping, outsloping, and crowning potentially of the road surface. The road drainage structures should be installed frequently enough along the length of the road such that the area draining to any one individual road drainage structure is minimized and there's little to no erosion at the outfall of that feature. To best hydrologically disconnect the road surfaces from the stream system, we want to place our very last and closest road drainage structure as close as possible to the water course, but not so close that it delivers directly to the water course.
And this particular rolling dip here, due to its proximity to the stream, has a unique opportunity to have a secondary best management practice placed within it. And what was done here was a sediment basin was excavated at the outfall of the rolling dip, such that any water or sediment that discharged off the outlet of the dip would be deposited into the sediment basin. And then that could thereby be maintained through excavation of that material as needed. This is kind of a unique circumstance at this location. Due to the proximity of the stream, any sediment and water will end up in that basin rather than in the stream channel itself. This is a road segment here that we worked on within the ranch, and the pre-existing conditions were such that we had about 1,200 feet of road length that was almost all insloped with an inboard ditch. And that was essentially drained to one point at the bottom of that reach that was a ditch relief culvert. Because of all the excessive concentrated road runoff, created a fairly significant gully within that system. In addition, all that fine sediment that was coming and generated off that road surface is being routed into the inboard ditch and down to that delivery point and subsequently right into the stream right below that. So because of that, this particular road segment was treated with a variety of these techniques that we're describing as part of this project.
The road was stormproofed by installation of 4 rolling dips along the 1,200 feet of previously hydrologically connected road. These rolling dips are connected to the cut banks, so anything in the inboard ditch, any runoff in the inboard ditch is drained across at the belly or the trough of the rolling dips.
Essentially what's going on here is we're breaking up that entire length of road into these small drainage area segments. So what was previously a 1,200 feet of road and ditch and cut bank has now been broken up into a few 100-foot long segments based upon the road grade, the road shape, to really effectively bring that into these small drainage units that minimized the erodibility force of the water as it discharges at those locations.
Prior to treatment, this road was a flat surface roadbed with an inboard ditch and relatively few drainage structures that would clear water from the road surface. Road surface runoff would be concentrated on the road surface, accelerating erosion processes. The road surface had well-developed rilling, gullying, and washboarding. When we treated this road, we treated it through the installation of rolling dips and localized outsloping. The location of this road is immediately adjacent to Lower Case Creek, so it's particularly sensitive receiving body. The rolling dips on this road, because it's relatively low gradient, all have reverse grade, which is an important feature to ensure that road surface runoff completely drains from the road surface. Reverse grade is the feature of the dip where you're driving down the road, you enter the trough of the dip, and then you actually have to drive upslope again to crest the dip while you're going down the length of the road. This ensures that all the road surface runoff is cleared from the road at the rolling dip location.
If you'll note here, this particular dip was placed at a location that's just above an alluvial terrace. So the outfall from when the dip is discharging out onto the flat alluvial terrace, any sediment and water will be deposited onto that surface prior to entering into any water body. All right, so this is a recent stream crossing upgrade here in a coastal stream in Mendocino County. And some of the major components of what was done here, we had an undersized culvert with significant erosion associated with that. So what we've done here is we've placed a properly sized culvert, sized for the 100-year discharge and large woody debris and transport. And so this ends up being an 8-foot culvert here placed in the stream bed. And we wanted to place the culvert in a manner that's actually within the natural channel valley alignment and at the natural grade of the channel. That way it could effectively convey and transport sediment through the pipe rather than depositing in a gradient sediment on the upstream end of the pipe here. On some of these larger size streams, we like to install what's called a single post trash rack. You can see that in the front of the culvert there. We generally put that at the culvert diameter above the inlet of the pipe. And what that does is help reroute or reorient wood as it's coming into the culvert inlet so that it actually could flow through the pipe rather than blocking and plugging the front of the pipe itself. Additionally, what we like to do on these stream crossing upgrades is put what we call a critical dip. And the critical dip is a mechanism, kind of a secondary mechanism, so that if the pipe does plug, when the water backs up and it goes back over the road, it will go back over the road and back into the same stream valley. A significant amount of erosion that's occurred historically is associated with diverted streams, where a stream will block, back up, and then flow down the road, and then thereby causing landslides or other diversion gullies at multiple locations. That's shown in many studies to be a significant portion of the overall sediment budget associated with road systems.
Looking at the downstream side of this recent stream crossing upgrade, you'll see that the outlet of the pipe has been placed at the base of fill to promote transport of sediment, debris, and water through the culvert. Fill slopes are best constructed at a 2-to-1 stable slope. But due to considerations of pipe length and curvature of channels and accommodating the best fit for the pipe within a curved channel, it may be necessary to build fill slopes at steeper than 2-to-1 degree slopes. In this instance, you would want to support the fill slope structurally with riprap or rock armor to provide some basal support for the fill slope and protect from surface erosion on the oversteepened slope. It's necessary in curvaceous channels, they're not all linear and straight line, to find the best fit alignment for the culvert so that culvert outflow isn't projected into a soft bank, resulting in additional bank erosion and reduction of bank stability, and that the inlet is preferentially oriented to efficiently receive flow from the upstream channel.
Here's an example of a recent stream crossing upgrade, and we're at the outlet here. And what you can see is the outlet has been placed down at the bottom of the natural channel grade here. We have about 4 to 5 feet of barrel extension past the fill slope. So any potential eroded material on above the fill slope will not actually end up in the stream, will end up along the side of the pipe. In addition, we have rock armor that's been placed along the base of the culvert outlet that helps buttress that fill slope in the upstream direction, where we have this approximate 2-to-1 slope above the rock, and this rock actually helps buttress that lower portion of the slope.
So you've used a variety of operators to install the various rolling dips and treatments on your roads. Can you speak to the benefits of using an experienced operator, someone who's familiar with installing these types of dispersive road drainage treatments?
Yes, we have used a multitude of different operators. It seems as though there's a fair bit of a learning curve. In particular, an inexperienced operator will have a tendency to make them too short, and they might make them a little bit more like a water bar, which makes it hard to get it over it, both with vehicles, people's cars, or heavy equipment and so forth. A more experienced operator seems to really know how to do it. They don't have to, they've been doing it, they don't have to learn it new on your project and do it improperly. The more experienced operators just do a great job. They get them deep enough, they get them long enough, they get them often enough. If it's a steep area, you need them more often. If it's gentler, you can spread them out further. These guys know that. And they seem to last longer, perform better. You're going over them, but they're not a hassle. And if they do them right, they're so easy to drive over, you don't even notice they're there.
So Stuart, you've used the Forest Ranch and Rural Roads Handbook treatments to stormproof most of your roads on the vineyard property. How has that worked for you? What kind of successes have you had using those treatments?
We've had really good success. We've been working with Pacific Watershed Associates for almost 20 years. And I'm very pleased with the results of the programs that you guys have designed. We've installed many of these things 15 to 20 years ago, and we continue to add and follow the same prescriptions today when we do work on roads that we haven't touched yet. And we've been very satisfied.
So you've installed many rolling dips throughout the property at the proper spacing based on road gradient and road surfacing. How has that impacted the necessity for maintenance on your roads?
I would say that maintenance is one of the things I'm most pleased with. Some of the, particularly the rocked road sections, once we put them in, there's virtually no maintenance at all. This main road here and a number of our other roads, once we put them in, we haven't had to grade the roads at all. We haven't graded the roads in over 15 years, and they're in great shape. Occasionally you have to clean a little bit of the sediment out of the very bottom of the rolling dip, but other than that, I think that they've required no maintenance.
Great, yeah. That's the way it's supposed to be.
Yeah.
Not necessarily eliminate the need for maintenance, but greatly reduce the need for maintenance.
I believe that putting in rolling dips is a small investment up front, but it has tremendous long-term financial benefits.
So the RCD requires that all projects have permits, and some of the permits are quite complex. And so we rely on our restoration partners to help us get those accomplished.
The permitting process ensures that the work will be performed to building code standards and also will be performed in alignment with best management practices concerning aquatic habitat, fish and wildlife resources, and other watershed resources.
The RCD really enjoys working with landowners, but we also take on a great deal of responsibility. So we have to make sure that we hire contractors who are experienced and qualified and licensed. And in turn, that includes the heavy equipment operators. They also have to be experienced and licensed. And so we feel like we bring this mixture of technical expertise and on-the-ground experience, and together they make a good project, a successful project. It's not something that you can just go out and do on your own if you're not experienced. So we look forward to hearing from you if you're interested in doing some of this work.
You know, successful rural road stormproofing can be somewhat technical and is best done by someone who has some level of experience with the practices. You can consult the Mendocino RCD or other engineering or geologic consultants to work with individuals who have a background in rural road stormproofing.
We recommend that people who are interested in pursuing a project or developing a project contact the Resource Conservation District in your community, or to contact a geologic consulting firm or an environmental consulting firm. There's also other agencies that provide help, like Natural Resources Conservation Service. We're all able to put people in contact with the information, including the handbook, and we're happy to be of assistance. Today's video is just an overview and a summary, and there's a lot more information contained in the Roads Handbook. If you'd like further information, please contact the Mendocino County Resource Conservation District or Pacific Watershed Associates. The Handbook for Forest, Ranch, and Rural Roads can be obtained through the RCD website and through PWA.
Thank you for your interest in the Forest, Ranch, and Rural Roads Handbook. Your efforts to stormproof and take care of your unsurfaced rural or ranch roads will protect watershed resources for generations.